Professor Pelton. This is trigonometry. This is Chapter 3, Section 2. This is the law of sines. This is Part 3 of 3. So the last part we're going to do is the area of triangles. So if you want to find the area of a triangle, it's not a right triangle, you're going to need to use one of two rules. The first rule we'll cover in this section, and the next rule we'll cover in Section 3 later on. So if you have a non-right triangle, oblique triangle, you can draw an altitude from any one of the angles and make two right triangles as a result. So now my base in this case would be C if I do that. So this is my base. And I have a height now of h. So if I do the sine using SOHCAHTOA, angle A is opposite over hypotenuse, right? Opposite hypotenuse. So if I solve for h, I get b times the sine of angle A. So therefore the base is replaced with C, and the height is replaced with b times sine of angle A. And that gives us the new area formula. But that's drawing the altitude from angle C down, which is this one here. But you could, of course, draw it down from A or B. That's why there's three variations. So in every case, whatever two sides you have, you need the angle that's included, basically. So you always have ABC, ABC, ABC every time. Okay? All right, so let's do some examples. So for the example, the diagram is given, but the diagram is typically not given when you do these problems. So the area here, if I do the problem, is 1/2 times the two sides which are given, which are 10 meters and 24 meters, times the sine of the included angle, right? So here I have A, B, C. So A is the angle, which is 62 degrees. So the area equals 1/2 times 240 meters squared times sine of 62 degrees. So the area equals 120 meters squared times sine of 62 degrees. So therefore the area, if I do this in the calculator, make sure it's in degree mode since you're putting in 62 degrees, is about 105.95 meters squared. So about 106 basically. Okay. All right, pause the video and try the student problem. Okay, so again, we have the area equals 1/2 times the two sides that are given, which are 8 and 12. Oop, not cosine, we need sine. Times the sine of some angle, which in this case will be 135, because if it's A, B, and C, the angle needs to be the angle that's not of the two sides given, so in this case is 135 degrees. Okay, so the area equals, let's see, 1/2 of 8 is 4, 4 times 12 gives me 48. In this case it's meters and meters, so that's meters squared times the sine of 135. So therefore the area is approximately 33.94 meters squared. So about 34 basically. Okay, let's go to the last page. We also need to be able to apply the law of sines. So here in this case we have two fire stations, A and B, and there's a fire out in the woods somewhere. So they take their readings, and what's important is a lot of students will just take those readings as the angles in the triangle, which is not true. So the first one is 50 north 50 by east, which is right here. So this is your compass right here. So that is your north-south compass. So that is your bearing, which is not the angle of the triangle. And this is your other one for B, which is north by 36 degrees west. Right, that's right there. But again, do not take the bearings as the angles in the triangle, which is a common mistake. You either draw the triangle, figure them out from there. So I know this must be 90, because every compass is parallel, so an east-west line must be perpendicular from there. So as a result, I need to get angle C as my last angle. So 180 degrees minus the other two angles, and that is angle C. Right? So angle C is 86 degrees for the final angle. Okay? So now I need to figure out the two missing sides here, which are A and B. But the only ratio I know is this ratio, C. That is the only ratio I know. So I have to use that one every time. So the sine of 86 degrees over the 20 has to be compared to the A side and the B side. So I have to compare it to A, and I have to compare it to B. Okay, we use the corresponding angles. So for A, it's 40 degrees. And for B, it's 54 degrees. Okay, so we set to solve two different problems and compare to figure out which one is actually closer. So we'll do our cross multiplying. So if we cross multiply, I get A times sine of 86 equals 20 times sine of 40, and divide by the sine. So A equals 20 times sine of 40 over the sine of 86. And A is approximately 12.9 miles. Okay. All right, let's try the other one. Cross multiply. I get B times sine of 86 equals 20 times sine of 54. And we'll divide by the sine of 86. So B equals 20 times sine of 54 divided by sine of 86. So B is approximately, what you should notice is, if you look at these two, the only thing that differs is the angle. That angle, because we're using the same ratio every time. So if you actually think ahead on a lot of these problems, you can do half as much work and just change the one number in a lot of these problems. So think about it ahead of time. Okay, so put that in the calculator. I get about 16.2 miles. So in fact, in this case, the A is closer to the fire. Okay? All right, pause the video, try the student problem. Okay, so in this case, we have a overall triangle that's a right triangle. We have a little triangle that's a right triangle. We have a little triangle that's an oblique triangle. So we have three triangles here, right? We have the overall right one, a small right one, and a small oblique one. Okay? So the goal here is to figure out this distance, given what we have, which is at this point, one distance and two angles. Well, first off, we know that this has to be 180 degrees for a straight angle. So if that's 58, the remaining must be 122 to give me 180. So now I have two of the three angles in the oblique triangle. So if I add the 122 and the 24 together, right, that gives me 146, leaving me with 34 for the last angle there. Okay? So we got to think about, in the oblique triangle, what sides do we actually have to know? Well, we want this one right here, which we'll call side C, or the hypotenuse side of the right triangle. Okay? So since this is a non-right triangle, we have to use law of sines. So if we do that, the only ratio I know is the sine of 34 to the 4.6 nautical miles. That is the only ratio we know. And if we want to find side C, that has to go with the 24 degrees, which is across from it. So that's the sine of 24 degrees over side C. So we'll do our cross multiplication. So C times sine of 34 equals 4.6 times sine of 24. And we'll divide by sine of 34. So cancel, cancel. C equals 4.6 times the sine of 24 over the sine of 34. Okay, so we're going to keep that and not get the decimal approximation here, because C is not our final answer, D is. We want to know D, right? That's all we want to know. So if we go to triangle D, that is a right triangle, we can use SOHCAHTOA. So if we do side C and D, right, C and D, using the 58 degrees, that's opposite over hypotenuse, that is the sine function. So that means the sine of 58 degrees equals D over C. But we're solving for D, that's all we want, correct? So if we multiply both sides by C, we get C times sine of 58 equals D. But we already have C, it's over here. So I'm going to plug that in to our calculator and multiply that by sine 58, and you will get that D is approximately 2.84 capital N lowercase m for nautical miles is the correct answer, okay, or the approximation. So the question here is, do I die? Since the reef extends out 3 miles, and I'm 2.84 miles from the reef, from where the lighthouse is, that means I'm going to die. If I was more than 3 miles, I would live. But you're fish food at this point. That is the end of part 3.